Have you ever stopped to think about what it really takes to become a qualified professional? You know, not just the classes and the tests, but the entire system behind it all? Well, today we're going to pull back the curtain on exactly that, how a professional is literally designed, built, and verified. Let's get into the blueprint. So let's get practical for a second. How do you actually build a qualified electrician from the ground up? How do you take someone with just raw potential and turn them into a competent, certified pro that you'd trust with the wiring in your own house? It's not magic, and it's definitely not random. It's a process. It's engineering. And the official name for this process is curriculum engineering. Now, I know that might sound a little academic, a little dry, but think of it literally. We are engineering a career path. We're using specific, planned out components and systems to build a final product, a skilled, ready-to-work professional. So let's start with part one, engineering an expert. We're going to look at how this incredibly meticulous and structured process actually gets the job done. See, the heart of this entire engineering system is one single idea: integration. It's not just about showing up for a class. Every single piece of knowledge, every hands-on skill, every bit of real-world experience, they're all individual components, sure, but they're designed to fit and function together like a high-performance engine. One gear just can't turn without the others. Which brings us to part two, the three-part blueprint. The whole system is built on these three core, absolutely inseparable pillars. So let's break them down. And this chart really shows the perfect balance of the system. You've got your knowledge component, your practical skill component, and your workplace experience component. Now notice how they're all equal parts of the whole. One isn't more important than the others. True, rock-solid competency requires all three in equal measure. So to put it even more simply, you've got the theory, that's your foundational book-smart knowledge. Then you've got the workshop. That's where you get to apply that theory in a safe, controlled space. And finally, you have the real world, where you have to prove you can do it all when it really counts. All right, part three, from theory to practice. Now, let's zoom in on that absolutely crucial link between the first two components. How does this system make sure that what you learn in your head actually translates to what you can do with your hands? Well, it's all about connecting the thinking with the doing. This table here illustrates that connection just perfectly. On the left, you've got the cognitive stuff, the theory, the what, learning Ohm's law. But on the right, you've got the psychomotor, the physical skill, the how. So you see, it's not enough to just memorize that V equals I times R. You have to be able to use it to calculate the resistance on a real-world component. It's a direct, engineered link between thinking and doing. But okay, how do you prove you've mastered both sides of that equation? Well, you need specific kinds of evidence. Knowledge, that's proven with things like written tests and explaining formulas. But practical skills, they're verified through hands-on lab tasks, trade test simulations, and actually showing that you can handle the tools of the trade. Every piece of evidence is a critical checkpoint in that engineering blueprint. And that brings us to part four, the real-world test. So you have the theory, you have the workshop skills. Now comes the final boss, the ultimate test of the whole system, proving you can do it all in an actual work environment. The evidence required here isn't some abstract idea. It is tangible and super specific. We're talking about detailed logbook entries of your daily tasks, official records of site visits, maybe even giving oral presentations on work you've completed. It's all about creating a verifiable, traceable record that proves your real-world competence. And this quote from the source material really drives the point home. That logbook, it isn't just a diary. It's a legal, evidential document. It is the final, definitive proof that you have successfully completed the blueprint by applying your skills where it matters most. So, let's talk about the payoff in our final section. Why on earth would we build such a demanding, complex engineering system? What's the point? Well, it all boils down to trust and opportunity. For employers and the industry, this system provides a traceable framework that proves you're competent according to national standards. It means your qualification is valid, it's reliable, and it's totally auditable. But for you, the individual, the benefit is crystal clear. It lines up your skills directly with what the industry needs, making you way, way more employable. So, when you think about it, a certificate from a system like this is so much more than just a piece of paper. It is a seal of quality. It's verifiable proof that you have passed through a rigorous engineering system that was designed for one single purpose: to produce a competent, trade-ready professional. And this really leaves us with one final thought, doesn't it? We've just seen how a really complex trade can be methodically engineered with a clear three-part blueprint. So it kind of makes you wonder, what's the blueprint for your career? What are your core knowledge, practical, and real-world components? And maybe more importantly, how are you proving them?